this whole packet today. We're just doing part of it. Factoring polynomials, day 1. Always factor the GCF first. Then we have to choose what we do next according to number of terms. I'm just going to take it off. If we have 2 terms, do you remember what kind of factoring we do? What it's called? It's not factoring. Square root is not factoring. But it does have something to do with squares. It's right here. Here's an example of 2 terms that we could factor. What's that kind of factoring called? Okay, so we are going to review vocabulary. Difference of squares would be if you have something like x squared minus y squared. And how would we factor that? We would do x plus y, x minus y. That's difference of squares. There is something new we are adding to today that I'm going to wait till we get to that page to teach it to you, but we're now going to have a sum of cubes. We're also going to have sum of cubes today. The sum of cubes could look, hey, I'm talking here. The sum of cubes could look like a cubed plus b cubed. See how we have cubes. So that's going to be new just in a moment. All right, if we have factoring 3 terms, that would be like ax squared plus bx plus c. What kind of factoring do we use for this form? That's not factoring. That is called complete the square. That is not factoring. You guys you're in that frame where you're solving. Factoring is one of those methods. Factoring is one of those methods that we use to solve, but how do we just factor? We do 2 parentheses. We look at the signs, right? It's called, I'm writing it down. Yeah. Okay, so that's the method that we use. There are other methods. There was a perfect square trinomial method, but we didn't really, this works just as good. Okay, and then factor 4 terms. Do you remember what we do if we have 4 terms? I'll give you an example. It's not got numbers in it, but what? What do we do when we have 4 terms? Nope. Factor by grouping. That's where we're going to put parentheses in there, and we'll start factoring from there. So this is why we're taking a moment, a half a second, to review this stuff, because some of us have forgotten it. Not everybody. Some of us didn't learn it in the first place. And not to scare you or anything, but this stuff is going to keep coming up.
Is this going to be on the exam?
Of course it will be.
Oh my.
It will also be on your second semester exam, because this is going to keep coming up over and over and over again. Oh gosh, I cannot wait. I can't wait to get to chapter 7 with you. Yeah.
So in the
We do a lot of factoring.
in the event that I have you again for the next year, which I hope,
because you're doing well.
Because you always help me, like my other math teachers, especially Ms. Cohen.
No, would you like me to pause this?
Are we going to have this on the exam next year?
It will look more complicated, but yes.
Wait, is that algebra? Is that like the next step up?
All right, so we're going to factor these polynomials complete. Oh, I didn't finish this last thing. So these are the different ways of factoring, but in this section, because we're doing higher than quadratics, you're going to see like cubics and fifth power. So after we're done factoring, we always have to check to see if it factors further. Okay, so factor each polynomial completely. What is the GCF? Okay, so we're going to factor out that x. Same stuff we've done before, right, guys? Okay, so x squared minus 4x minus 5. So that's factoring out the GCF. This is a trinomial, 3 terms, so it looks like I need to do guess and check. Okay, so your desk is not glued to the floor. So you can move it wherever you need to so you can see. You can pull it all the way up here next to Bryce if you want.
Yeah.
So I'm going to put in my 2 parentheses, but I do bring down that GCF. This sign right here tells me what about my signs? 2 different. You have to know this stuff. And then the first sign tells me that the bigger one's going to be negative. So what's going to multiply together to give us 5? 5 and 1. So my bigger one's going to be negative. Oh, I forgot my x's. Whoops. Now, it's called guess and check. You have to check it. You have to check it. So we're going to multiply back together just to make sure we did it right. And that becomes a minus 5x. And that becomes a plus 1x. Does that add to give us a negative 4x? Yes. Now, can x plus 1, which is a binomial, be factored further? If the degree on this is 1, it should not factor further. If the degree is on this, 1, it should not factor further. We're only going to factor further if there's more x's to separate. So this one's done. Question B, what do we do first? Okay, the GCF is 3y to the third. So I got 3y to the third. I get y squared minus 16. And we say, is this y squared minus 16 to the first power?
No.
Well, perhaps it can be factored further. So we go up here and we say, is it a difference of squares?
It can be y and y and both
Oh, yeah. So 3y cubed and then y squared minus 16 is a difference of squares. D-O-S. So we can go y plus 4 and y minus 4. Difference of squares. I just made it up right now. I don't know. Okay, I will never use that ever again. Is there a GCF? 5z squared. So I'm going to have 5z squared out front. We're going to have z squared plus 6z plus 9. Can that factor further?
Yes. No. Yes. Yes.
Well, let's guess and check. That would be z and z. Signs would be plus and plus. That could maybe be 3 and 3. How do I know if it's correct? So we're going to multiply back together and get 3z. Multiply back together, I get another 3z. Add them together, I get 6z. I factored it correctly. But why would Miss Criswell take off a point if you leave it like this?
Because you're come on now, G.
Because you know better than that.
Yes, you do, Martin. Especially you, Martin. Wait.
Okay, number 1. Oh wait, these are student practice. Do I want to do any of these? Nah, let's keep going. No, we're good. You turn. Go. Turn your pages. Go. Write it down. My nails aren't that bad right now. That's good. I'm going to. I have an appointment finally.
Appointment.
To get my nails painted.
Oh, that.
Finally. Hurry. There's no more bathroom breaks until I've gotten through this next section, because this is the brand new stuff. She did. Okay. This is called sum of 2 cubes.
Sum of 2 cubes.
Sum of 2 cubes. I even underlined and starred it. So this would be when we have addition between 2 perfect cubes. If we have addition between 2 perfect cubes, there is a formula. And I'm going to go through that formula, like I'm going to rewrite it. It's written right here. But I'm going to rewrite it so you can see how I use that. Yeah.
On testing quizzes and stuff.
You will have to memorize that formula.
Will this be on the test?
Everything is on the test.
Okay. So this is a cubed plus b cubed. And I'm asked to factor it, and I notice, oh, these are perfect cubes, and they're addition. So what you do first is you have to do, it's called a cube root. You ever heard of a square root?
Yes, and the cube is.
Yeah, I heard of a cube.
About
Is
that.
there such thing as a portrait? Like a full tower?
There's something called a 4th root, and a 5th root, and a 27th root.
They don't have special.
They might, but I don't know. This is what a cube root looks like. So, you know how I have 5 squared, and I ask, what's the square root of this answer? You would tell me 5. Yeah. So if I have 5 cubed, and I said, what's the cube root? That would be 5. It's like what times itself makes this number.
We've done this. I've done something.
Good. Let's make a list of some very common used cubes so that you have some reference.
Wait. I'm trying to think of one. What about the square root, the cube root of 24? It ain't like.
Nope. What is 1 times 1 times 1?
Oh my God.
What is 2 times 2 times 2?
Get out!
What is 3 times 3 times 3?
27.
4 times 4 times 4.
64. 64. Yeah. What I do?
5 times 5 times 5.
125.
25.
6 times 6 times 6.
I don't know.
36 times 6.
Yeah, tired. 336. I don't know.
216.
That's me.
I wrote it down.
I almost got it.
Keep hitting me. Come on.
Fine. What's 7 times 7? I don't even know. Yeah, I know what it is. 7 times 7 times 7.
Oh, I give up.
348.
Quit cheating with your calculator.
477.
Oh, dude, you see how close that was? We could just add a little
right.
squiggle.
You really don't need all of these, but you guys are just going on a roll. That's 8 cubed. You already looked it up. You didn't figure it out. Oh, you went and figured it out? Okay, never mind. I retract that. 9 times 9 times 9?
That's 81 times the
I already know the answer. Here's an easy one. 10 times 10 times 10.
1,000.
There we go. You knew that one.
One baby.
Oh, wait. Ha! Here's my list of perfect cubes. I knew we were going to do it. I just...
Oh, that's so.
I forgot I put it there. Okay.
What's that laugh? Who just laughed?
I like that laugh.
Okay, so now, if you notice we are adding perfect cubes, if you notice we are adding perfect cubes, if you notice we are adding perfect cubes, then you will use this formula. And it says you're going to just write a plus b. So if it's right now a cubed plus b cubed. So if it was like 5 cubed, what would go over here? Okay, right now this is a cubed. I'm going to put a plus b. So I said, what if it was 5 cubed? What would you put here?
You put
times A times
5 plus B.
Okay. We're just going to have to do some real examples without the formula, but I'm writing the formula. So this is what I always do. First, I take the cube root of this one and the cube root of this one. That's how I get A and B. I do cube roots. That's how I get A and B. Then, I take this answer, and I take it right here, and I square it. So I take the A answer, and I square it, whatever answer that is, and I square it.
Like, even if it's like A fifth, A2.
Sure.
We'll
get there. We'll get there with numbers. Okay, then what I do is I take this second number or letter, and I go all the way to the end of my next parenthesis, and I do B squared. Because I put it, yeah, there's something in the middle. Okay, guys, acting like sophomores, stop it. I know. I was just joking. Yeah, but you're acting like a sophomore. Okay, so then you always use a subtraction, and we multiply together A and B. You will use a subtraction, you multiply together A and B. And then this will be a plus sign here.
Okay, so it's A squared.
Can you make up a song for this one?
Can you?
Okay.
Not right now. Not right now. Not right now. Not right now. Okay. So that is the formula. With a real example of it, let's do this number 4 way at the bottom. So this will be a real example.
What's the rest of them?
It's on the paper. I was just recopying it. Right above where I was drawing. Okay. All right, so we're going to look at number 4, and we're going to see a cubed plus 27. Is a cubed a perfect cube? Yes, it's a cubed. Is 27 a perfect cube? What cubed is 27?
3.
That's 3 cubed. Oops, cubed. I know what I put.
Oh my god, I wish it was
It's just habit. Okay, so now we're going to start our formula for factoring. The first thing you do is say, what is cubed? What is cubed here? A plus what is cubed here? 3. So that's your A and your B. In our second parenthesis, you will square the first thing, which is A. So what's A squared?
A squared.
Yes. And then the last one, you're going to square the 3. So what's 3 squared? Okay. And then we always subtract in the middle the two numbers or two terms multiply together. So A times 3 is 3A. It is factored. Now, occasionally, we do have to check to see if it goes further. Will this A plus 3 go further? Or is this to the first power? Okay, so that will not go further. Could A squared minus 3A plus 9 go further?
Yeah.
So then you have to try guess and check. I'll give you a moment. Make sure you look at your signs. Try your guess and check. So what are your options for 9?
3.
Or,
1 and 9.
okay? Will I ever get 3 in the middle? Oh, that's right, because it's not factorable. But
Does it make A something though?
Why you just waste my opinion?
it's just a squared, so no. Okay, yeah, I made you do that because I want to tell you that this part here will never factor further. If you factor this by perfect cubes, this will never ever factor further.
Oh, yeah, because it's a perfect trinomial.
No.
I mean, it is a trinomial.
Yeah, it's a trinomial. It's not perfect. Okay, never ever will that factor further. Maybe sometimes the binomial will, but never will that factor further.
So is that problem finished?
Yep.
Oh, dude, that was easy.
It is easy.
Get a button.
Wait, so the second part will it on some parts of it will it be able to get back?
Never.
So the second part you
Never.
can never
Never.
ever
Never.
ever.
Yeah. Okay, now go back up to this A. This one's different. Teeny bit. What I circled.
Because it doesn't square and the cube.
Hold on. Is this a perfect cube? X squared, is it a perfect cube? Is negative 125 a perfect cube? Okay.
Yes, but we just went over this slide.
No, what we didn't go over is we didn't talk about the negatives. But when you do cubes, and you multiply negative times negative times negative, it becomes a negative. So negative 125 has a cube root of negative 5. So when I rewrite it, if it's subtraction, you can rewrite it as adding a negative. And then this is sum of cubes. So we're going to use our formula that says what was cubed? X plus what was cubed here? Negative 5. And then my other parenthesis, the first term, is to square that first term. X squared. My last term is to square negative 5, which is positive or negative. That's positive 25. And then in the subtract, the two of these multiply together. So what's x times negative 5? Negative 5x, okay? Now I'm going to simplify it. You are right. I'm going to simplify it. I'm going to actually rewrite this as x minus 5 times x squared plus 5x plus 25. Does x minus 5 factor further? If it's to the first power, it will not.
So, yeah, it can. Oh, yeah, it can.
Does this factor further?
Yes.
Never.
Wait, what?
It never can be.
Martin, will never factor further. Never. You can try it. You can try it and prove me wrong. But it's not going to work. All right, let's look at question B. What would I do first? Is there a greatest common factor?
Yeah, it's the S and the 2 and the squared. And probably 2.
Okay, there is a 2. And there is how many S's?
2, 3, or 2.
2.
Why?
S squared. Okay.
So I've got 2S. Why are we doing 2?
Because the second one got 2, and then we can just get rid of that S squared.
Which 2?
Yeah,
The
what?
number 2. No, like the question number 2.
Oh, why aren't we doing what?
What?
Actually, I don't know.
Okay.
It literally starts on number 4.
Oh, that's just what I chose to cut and paste. Okay, so I took out 2s squared. Can you guys please stop being disruptive to other people in here? 2s squared, I took that out and I got left over 8s cubed plus 27. And I see this cubed and I see an 8, I see a 27. Do we have a sum of cubes here? Is 8 a perfect cube? Is s a perfect cube? Is 27 a perfect cube? Martin, did we write 8 in this list? Did we write 27 in this list? Okay. So this is 2s squared, and then what is the cube root of 8? What times what times what? So it's 2 cubed, that's s cubed, and then what's 27? 3 cubed, okay? So we're going to use our formula. The 2s squared is outside of the factors, so it just comes down. Yes. We did 3 times 3 times 3 over here. Oh, you mean how to get the 27 in the first place? Yeah, we factored out a 2. A greatest common factor. Because they're both even. Chris, do you have a question? Why did I do this step? Just so when I ask my next question, you could answer me easily. This step, what I would say, is optional. But my next question is, what was cubed to give me 2 cubed s cubed? What was cubed? No. Listen to my words. What was cubed to give me 2 cubed and s cubed? What was cubed?
2 and s.
2 and s, right. So I write 2s plus, I'm going to say, what was cubed to give me 3 cubed? Okay, so that's our first parenthesis. Now our second parenthesis, we have to take the 2s, and what do we do to it? Okay, that means 2s times 2s, 4s squared. At the end, I'm going to square 3, so that is 9. In the middle, I do subtraction, and I just multiply the 2 together, 6s. Does 2s plus 3, the factor of 2s plus 3, factor further?
No.
Martin, does this factor further?
No.
It does not. That's what it is.
Any way to remember the steps for this?
Yes, by practicing. That, and if you forget what I say, because you didn't take good notes or whatever, just listen to my video again and watch me do it again. Watch somebody else's YouTube video. But I'm, biased. I like mine. Okay, just kidding. Mine aren't that great. What?
Here we got, like, in the parentheses, 8s cubed plus 27.
Yes.
What if the 8 wasn't, like, a cube?
Then you couldn't do it.
Then you cross it off?
Well, we could still do the GCF, but you couldn't do anything further. You guys, the question that Rachel has is a good question. Her question was, so let's say we factor this out, and instead of it being 8s cubed plus 27, let's say we had 2s squared times 7s cubed plus 27. She said, what would we do if this 8 wasn't there? What if we do if it's a different number and it's not a perfect cube? It doesn't go any further, you're done factoring. Because that's not a cube.
I like that.
Okay. Yeah, that doesn't happen that often in my class, though. All right, 6. What is our first step? Then do it, don't yell it. Do it, don't yell it. Do it, don't yell it.
I'm not sure.
Yeah. Thank you.
Oops.
Yes.
It's on the board. Under my hand. Okay, so we took out a GCF of 6z squared. You know why I put the little extra thing in the z?
So it doesn't look like a 2.
Right, because you'll get confused and you'll think it's a 2. Some people do. Okay, 6z squared times z cubed minus, so what is 125? That is 5 cubed. Or 5 to the third power. It's not 5/3.
Wait,
Yes.
why isn't it plus the negative? I just...
Oh, I'm sorry. Because I don't always do that. Because I don't have to do it.
Same
Yeah,
either way.
yeah. It's like that.
I just-
I'm sorry.
No, it's okay.
No, I wish I had done that now, and I just, all this talking is distracting to me.
I'm sorry.
Should be. Okay. That's cute. All right, guys. So as Rachel pointed out, because this was subtraction, we kind of want to put it as plus and negative. So we're using our same formula for all of these. So when we put this in here, when I go over here, I'm going to have what cubed gives me z cubed? Z plus what cubed gives me negative 5 cubed? Negative 5. Now we're going to square it. Z squared, we're going to square the end to get positive 25. And we're going to subtract the 2 multiplied together, negative 5z. Who has a question? What? Oh, in real life? Probably nothing. Because you have to learn how to pull things apart, put things back together. You have to learn problem solving. We're going to, if you get to higher level math, you'll be using this more, but unfortunately this class is not designed to every single person's individual career.
I'm a music producer, so I don't need
Yes, but like you need problem solving skills.
No, I'm just
No,
completing high school.
no. You need, Devin, do you ever have problems in your music producing where you have to solve a problem?
It was once where I had to copy that. Like once. Hey, you need basic math.
You don't have to.
I ain't even going to lie. You need basic math.
No, you do. But you don't have to explain it to me. I'm just saying you don't necessarily need math, but you need logical thinking and problem skills, which is what I'm giving you right now.
Oh, that's true.
So that's why the state of that's why the state of Ohio requires you to take through Algebra 2.
What state does it?
I don't know.
Who's to that state?
Okay.
I know.
We are going to review the section. This is now review. Yes, get it off of one of them. Okay, the last section is just reviewing factor by grouping. So factor by grouping, the first thing that you do is you notice, oh, there's 4 terms. Is there a greatest common factor? Okay.
Yes.
You have to have a plus sign in the middle, just kind of like what we were doing with the sum of cubes, how we did plus a negative. You have to have a plus sign in the middle before I start grouping them. So there I grouped them. Now, in the first group, we have to factor it. So just looking at that first group, what is our first step of factoring? That's not a step of factoring. What's the step of factoring?
Divide z squared.
The GCF, right? You guys are telling me what to do, not what I am doing. So we're, that didn't make sense. Never mind. Z squared, factor out with the GCF, Z plus 5. Now, I go and I look at this other parenthesis. How would I factor this parenthesis? Factor out a negative 4. And then when I factor out that negative 4, I am left with z plus 5. Now, I hear what you're saying. We're trying to manipulate this. We're trying to take out the negative 4 so that these are going to be exactly the same. Like, that's what we want to have. Yes, Martin?
So would it be z squared minus 4 and then z plus 5 squared?
No. So now what we do...
We did it a lot of times. You put the bracket, you put some brackets underneath z plus 5. Yeah.
So now what we have is we have a binomial. So we're going to factor again with this binomial. What is the first step of factoring always? GCF. Is there a GCF here?
Yeah, z plus 5.
That's the
That's what I was talking
GCF.
about.
I know what you're talking about. So we're going to factor out that GCF. So that GCF comes out, z plus 5, and it cancels out, just like we do GCFs all the time. And then what's left over in the parenthesis? Z squared minus 4. We have, that's why I said it was review. But guess what? We aren't done. Because z plus 5, is that to the first power?
Yes.
Okay, well that one's done. Is z squared minus 4 to the first power?
No.
So now we have to go back through, our how we factor stuff, the flow chart, and this is two terms. Is it a difference of squares? Is it subtracting two perfect squares?
Yes.
It is. Our next step, we bring the z plus 5 back, and now we have to factor our difference of squares, z plus 2, z minus 2. Sorry, I just want it recorded. That's why I sometimes interrupt you. If I wasn't recording, it'd be different. Now we have to go back and check again. Is z plus 2 something we can go further with?
No.
Why not?
Because it's
First power. How about z minus 2?
It's to the first power.
To the first power. So this is our final factored form. Linear.
Hey, look, this form, when you factor it out completely, that's easier than just factoring it out.
What do we have this class?
Okay, we still have 11 minutes of this class now. So
No, like, when do we have class?
2 days. 2 days.
We have it again.
Okay, student practice. You guys, we are not done yet. Let's look at this one.
Hey, I give up on that.
How many terms?
4.
Is it a plus sign in between?
No.
You gotta make it plus.
Plus a negative. And then when I draw in my groups, the plus sign is the only thing in between. In my first parenthesis,
Divide x squared. The GCF.
so what's left over is x plus 4. Second parenthesis, what do we factor out? It is a 1. It is a negative 1.
If it's like a negative 1, I just say factor out.
What?
If it's like a negative 1, I just say factor out. That's all I.
Okay, so I get to this step here, and now we think about this being a binomial that has two terms. Within these two terms, is there a GCF?
Yes,
X plus 4. X plus 4. I do it in my head. But I'm redoing it again because it's been a while since we've done this. Okay, so now I have x plus 4 and I've got x squared minus 1. Is x plus 4 factored all the way?
No. Wait, no, x plus 4, yes. It's just x minus.
Okay, x plus 4 is factored all the way. Is x squared minus
No,
1?
it's x plus 1 and then x minus 1.
What kind of factoring is that? No.
Did you just say linear? Get out.
No. What kind of factoring is it called?
Difference of squares.
Difference of squares. And then those are linear, so we're done. Can we look at A?
I mean, we.
Well, can we do A real fast?
Not fast. I mean, but
No, I'm going to do fast.
we got 10.
I know, I'm trying to go fast. 16x to the 4th minus 81. What's our first step? Is 16 go into 81? Is 4 go into 81? Does 8 go into 81? 9 goes into 81, but 9 don't go in there. There is no GCF. We move on. It is two terms.
Difference of squares.
Is it a difference of squares?
You can do, at first, you can do this. At first, you can do this. You can do 8x
Back to
squared.
two terms.
You can do 8x squared.
No.
Dang it.
Oh.
It's a difference of squares. So we write it as 4x squared plus 9, 4x squared minus 9. Then we say, are we done?
No.
So let's look at the first one. Is it linear? No. Is it a difference of squares.
Yes. No, wait.
Yeah.
No, it's not. It's not.
Yeah, yes, it
Martin,
The second one is.
is this a difference of squares?
No.
Because the word that I'm saying makes it not a difference of
Difference.
I'm saying the word difference, and this is a sum. This one is done. Is this one a difference of squares?
No.
Whatever Martin says, it's the opposite, so.
Yeah, let's listen to Martin.
No. Who needs to leave? Who is that? Who was that? He said it himself?
Yeah.
Martin.
Martin.
Hold on.
We
You
talked
know I
about
love
that.
you.
Well, we all got little.
Just kidding, just kidding, you said that out
We
of
just gave one of these chance. Alright?
Oh my
We all love you, bro.
Bro, if I
We
said
just
dog,
hate when you say something.
Okay, we now have 6 minutes. So this is factored all the way.
We just had to solve with just Martin.
Can we look at question B? Is there a GCF?
Yes.
What is that?
3 squared. 3p squared.
Oh, 3P.
That's not how I said it, though. That's just not.
This is the one I really need you to pay attention to. Okay, so we factored out our greatest common factor. Now we have something that is in that form of ax squared plus bx plus c. It just has different powers, but don't worry about it. We are going to factor that by guess and check. It looks like my signs is going to be plus and plus. And the 6, I can figure out what multiplies. Yeah, 3 and 2. So, but what's going to go here and here to give us p to the 6? We got to do p to the 3rd and p to the 3rd.
Wait, how do you know what power it goes by?
It's okay. So let me multiply it back together so you can see why. Okay, so if I multiplied it back together, I'll just like multiply the whole thing back together. Here we'll even do a box.
Ooh. Box man.
Okay, so what's 3 p's multiplied by 3 more p's? P to the 6. Over here I've got 3 p cubed. Here I've got 2 p cubed. And when I add them up, I get 5 p cubed. And then 6, 3 times 2 is 6.
I keep hearing P.
Yeah.
Oh, so you can just take the middle.
Right. So I have a worksheet for you. It's all factoring review.